Nowadays, there are around 150 million pieces of junk that are too small to be tracked by radars. In order to avoid this menace, satellites and the space station need to be protected. In Freiburg, in Germany, scientists from the Fraunhofer Institute test shielding material using a superfast accelerator known as a space gun. This space gun fires tiny metal balls at various shielding materials. This series of chambers reproduces conditions in space. They are filled with light gases and accelerate the balls close to the same speed as orbital debris, 15,000 miles an hour. At this speed, the behavior of collisions is very different from that on Earth, during a car crash, for instance. When a car hits a wall or another car at 30 miles an hour, it is deformed, and thousands of pieces of debris are created as the material fragments. But at hypervelocity, speeds above 6,700 miles an hour, a collision creates different physical phenomena.
In high velocity impact, the particle is fragmented. So parts of it are vaporized and ionized, and the other parts can't withstand the really huge pressure loads which we have behind the shock wave.
In hypervelocity, a 1 millimeter ball has more energy than a baseball flying at 60 miles an hour. Reinforced doors protect the laboratory. The high-speed camera, which films more than 1 million frames per second, records the moment of impact. As a safety precaution, no one can stay in the room while the space gun is being fired. The results of these tests on different satellite components are then analyzed.
For the International Space Station, we tested several shields, but we also try to test the components like space solar cells or components like tanks, which are located behind the walls of a satellite.
Using ultra-slow motion images, the space gun team manages to understand and model what happens during a collision. Their work allows them to come up with structures that are both light and resistant to hypervelocity impacts. They have just proved that doubling or tripling insulation layers can protect satellite components hit by debris smaller than 4 inches. The first layer fragments the debris. The second dissipates its energy and protects the third layer. Thanks to these experiments, scientists have been able to design satellites that are resistant to small debris. But even today, we are unable to protect astronauts when they are outside their vehicles during spacewalks. They remain exposed to small debris that can't be detected by radars or seen by the human eye since they are traveling so fast. Even a minor impact would puncture an astronaut's suit and lead to instant death. Because of this risk, NASA is actively developing robots that could replace humans to accomplish maintenance operations outside the spacecraft. Though even robots would be unable to withstand a collision with debris of more than ½ inch. Obviously, the less debris there is, the better. Countries around the world have tried to establish rules for the non-proliferation of large debris. as they have done for land-based nuclear weapons. For example, satellite operators are asked to empty all fuel on board their space vehicles. All rockets are equipped with systems to vent or burn excess fuel, a system that is tested on the ground before each launch. Satellites are limited to a maximum 25-year lifespan in orbit. Finally, objects in low Earth orbit that do not completely burn up on re-entry are steered towards broad ocean areas for their final impact. However, these rules are not always respected, particularly since there is no governing body to police offenders. And as time passes, the amount of junk increases.
We're generating debris faster than it can clean out by the atmosphere. And that's what we refer to as being an unsustainable environment.
There's only one real solution to this problem. Clean out the debris that is orbiting around the Earth.
Well, you have to bring back some of the objects that we've left in orbit.
Based on the polluter pays principle, each country is supposed to finance the elimination of its own debris. Since 2013, space engineers have been creating a new profession: space garbage guy. The idea is to come up with robotic systems that can deal with large pieces of garbage by sending them into a junk incinerator, the Earth's atmosphere. But it's a difficult task, since orbital debris moves like an asteroid, spinning around as it orbits because of gravity. Around the world, laboratories have been coming up with robot satellites that could capture debris and deorbit it. That's what they're working on at the Remove Debris project at the Surrey Space Centre in England.
In a real mission, you'll be dealing with uncooperative debris that may be spinning.
Space engineers use technical terms, but their projects seem more like children's games.
One of the technologies we have on our mission is the harpoon.
It seems unlikely, but the team is developing a harpoon capable of attaching onto a piece of debris in order to drag it into the atmosphere.
In our mission, the Remove Debris mission, the thing we're actually testing is the impact mechanism of the harpoon on an actual target plate.
The team is still at the experimental stage, where it is testing a miniature harpoon on a stationary target. First attempt.
3, 2, 1, fire!
Failed. The harpoon did not leave its sheath because of an electromagnetic problem. Second attempt.
Hopefully the harpoon should be able to impact exactly where you want it to hit.
3, 2, 1, fire!
The trial and error method is a long process, but the team is improving its system. The first full-scale test in space in 2019 was a success.